Which side am I coming from? Am I going to come from the left or the right? Or from above? That'd be really weird. Okay, I'm coming from this way. Ah, you couldn't see because there wasn't a shadow. That's why I did that. I'm awesome. Okay. Probably going to be the last video on these formulas for exponential functions because we need to move on a little bit and we need to move quickly. So we're going to quiz on Thursday. Yeah, we're going to quiz on Thursday. I'm going to give you the formulas on the quiz though. So I'm going to provide them to you because I need you to have plenty of practice with, first of all, knowing what they are because you may or may not be getting them on tests and quizzes, on tests and state test, something like that. I don't think you will. So I want to make sure that you're aware of them. So go ahead and pause me. Without the help of notes or anything like that, go ahead and try to remember, write the 4 or 5 formulas down and understand what each part means. So we're going to do that now. And I'm just going to give you a couple of tips with regards to which formula you use at what time. Okay, so we're talking about exponential functions. Now you can go ahead and pause me or unpause me or whatever you've done because we're going to do these. So I'm going to erase this nice orange craziness here. Okay. So the first formula, the one we started with was geometric sequences. Okay, so geometric sequence. Okay, I want to make sure I have enough space here. I'm going to move this over. Okay, geometric sequence. A sub n equals a sub 1, parentheses r to the n minus 1 power. Tip number 1. This is the only formula that has a minus 1 in the exponent. Only one. It's the first one we did. It's the only one that does that. Why? Well, we'll get into that later. It's not really that important just yet. So what does each part mean? A sub n is which term am I looking for? Okay, and that also is for this n. A sub 1 will always be the first term. And R stands for the common ratio. Please remember that. It is super important. It is the common ratio. Okay? So common ratio indicates multiplication only. We are never dividing, moving upward, like forward in time. We're never dividing, we're never adding or subtracting. It is always multiplication. Even if the multiplier is a fraction, that's how exponential functions go down. So it gets from a big number to a small number. Okay. So geometric sequences, first one. Number 2, I'm going to use a different color because I've got 400 colors here. Just go straight blue here. Okay, next function, exponential. So I'm going to go expo growth, and we'll throw in decay because they're super similar. Formula for that, and I'm going to use y here. Don't worry about why I'm using y. Y equals a times the quantity of 1 plus r to the t power. Okay, the Yart formula. And then decay is obviously the same exact thing except there's a minus sign. Y equals a times the quantity 1 minus r to the t power. Okay, so a stands for the initial term. It's kind of like the first sequence formula we did. It's the initial term or the first term or whatever you start with. And r stands for the rate as a percentage, but always change the percent to decimal, always. And then t stands for time, whatever the context of the question is. Same thing for this formula, it's the same exact thing, okay? Exponential growth and decay. Pretty simple, right? Pretty easy. All right, next formula. Let's go with half-life, because that's a little bit easier to remember. Half-life, am I gonna have enough space if I go over here? No, let's go here. No, let's go here, I lied. No, let's go here. Half-life. Okay. This one's also a very simple formula. Y equals, and I think I said it was P, but we can do A if you want to keep it. It doesn't matter what the variables are. A times the quantity of 0.5 to the t power. Now this is the crazy one that you have to definitely remember. So A stands for the initial term, again. 0.5 is always the rate, you don't have to worry about that. And T stands for cycles, that's a Mr. D exclusive. Okay, Mr. D exclusive right here for you, dropping this on you right now again. Cycle stands for how many times the half-life occurs in the duration. So remember that fraction we did to help you remember. So T is going to equal, what did we say, total duration over over actual half-life. Of, I don't know, substance. Okay, so if it was, so dramesium, right? If the half-life of dramesium was 10 days, and you wanted to see how much was left after 40 days, so it would be 40 divided by 10. So the cycles, the 4, would go here as the exponent. Oh, my eraser. Okay. Last formula, definitely the craziest formula to remember, but it's just a step-by-step process. Oh, I don't have a red. No, I need a red. Blasted. And yes, I'm going over here to get a red. Not kidding. That's how I roll. It's not really red. It's like a darker red, but it's awesome. Okay. Oh, yes, brand new Expo. Okay, compound interest. It's so smooth. Look at how smooth it writes. Compound interest. My handwriting gets better when I have a new Expo marker too. I don't know. All right, so compound interest. Long video. Okay. Compound interest. It's the print formula, right? So y equals the initial term times the quantity of 1 plus. Now it's the rate in the numerator and number of times compounded in 1 year in the denominator to the n times t power. Okay, so it's the print formula. Typically I'd have a p there, it doesn't matter. Again, initial term, initial amount, rate as a decimal, just like exponential growth and decay. The n's stand for how many times it's compounded in 1 year, okay? And t stands for years or time again. So basically, compounded, if it said interest is compounded monthly, well, how many times does monthly happen in 1 year? 12. If it's compounded quarterly, how many times does quarterly happen in 1 year? 4. If it's compounded annually, and this is one you'll see often because it's tricky, how many times does annually happen in 1 year? 1. Okay. It won't say daily because no bank would ever give you daily compound rate, but it's 365 if it was that. And don't worry about leap years and February and all that kind of stuff. We have a February 29th this year. It's kind of weird. Okay, anyway. So there are the 5 formulas. 1, 2, 3, 4, 5. Okay, now what's similar with these formulas? Okay, well, what's similar is I always have an initial term, all of them. I have a starting amount or starting number. What also is interesting is there's always parentheses here, which is going to indicate some number that is being raised to an exponent, because that's happening every single time. So, starting value, some number being raised to an exponent. Starting value, some number raised to an exponent. Starting value, some number raised to an exponent, even though it's still cycles, it's still an exponent. And some number raised to, initial value or starting number, some number raised to some value. They're all the same. Exponential functions are all the same exact thing. Some ratio, some common ratio, is being multiplied to some exponent and then being raised to some exponent and then being multiplied by some top number, some first number. Okay, so all of these things are exactly the same. They're just a little bit different with regards to what you're looking for. Now, geometric sequences will always give you a common ratio. Half-life problems, they will be always science-y, meaning they're always going to give you some kind of an element or something that says half-life. It will say half-life every time, okay? Always we'll be able to pick out which one to do half-life with because it says half-life. The half-life of carbon, the half-life of dramesium, the half-life, it won't actually say that because that's not a real element. Half-life of, I don't know, some other weird element. Compound interest, you will always be able to know a compound interest problem and when to use this formula because it will say the interest is compounded blank, like monthly, annually, semi-monthly, semi-annually, semi is two, right? So things like that. It will always say interest is compounded blah. Now, if you have a problem that involves money, like a starting amount, a bank account, and it's going up or down or whatever, if it does not say compound, it actually physically has to say compound. If it doesn't, you are going to use exponential growth or decay. Okay, so if it does not say compound and it's a money problem, you're using exponential growth or decay. It's the only way you're going to be able to use it. And you will be able to pick that out for sure. Okay, so that is going to be a challenge. I will definitely put that on your quiz on Thursday. All right, 10-minute video. Serious. Try some problems. I think the fever is indicative of giving you some more problems with that because we need to know it. Okay? Fun stuff. We're moving quick. I know it's fun. All right, maybe it's not, but whatever. We have to do it. All right, goodbye.